Let's take a look at the complex number system. And the first thing we'll take a look at is what's called an imaginary number. So we've got definition of I, which represents the imaginary number. Whenever you have a square root and you have a -1 inside, that's what gives you an I. Now we also have something called standard form. Which is of this form, a plus bi. And a and b are typically numbers. So you got a real part and you got an imaginary part. Always, even if it doesn't say it, you should always try to write it in standard form, where you have your real part separate from the imaginary part. I've been told, I've never taken any courses in it, but I've been told that this is used in electrical engineering, that it's a very valuable tool for them in their design work. So let's take a look at these and apply them to some problems. So our first one here, we got the square root of -16. And the instructions say write each expression as a pure imaginary number, but we always, even if it didn't say anything, you should always simplify a radical when you run across it, a square root or whatever it is. So for this one, I can rewrite this as -1 times 4 times 4. Now remember, with square roots we're looking for pairs of something. Here's a pair of 4s, so this pair of 4 is going to come out in front as a single 4. So that gives us 4 square root of -1. And we just said that a square root of -1 gives us an I. So that gives us 4i. Basically, a negative inside of your square root just comes out in front as an I. You can think of it that way. You don't have to actually show that step each time. Let's take a look at another problem. We've got square root of -40. Again, you should always simplify your radicals before you go on. So we got -1 from the negative. 40. It's 2 times 2 times 2, 4, 8 times 5. Okay, so we're looking for pairs of something. Here's a pair of 2s. They're going to come out in front as a single 2. We also have a -1. Remember, the -1 comes out as an I. So this is going to give us 2i. And we're left inside with a 2 and a 5, but again, we have to have pairs of them, and there's no pairs, so 2 times 5 just gives us 10. So our answer is 2i square root of 10. Now some books get kind of rigid about this, so put the I at the very end. And some books will put it in front of the radical. The problem with putting it at the end is if I put it here, it's pretty clear what's happening. Consider that versus this right here. Is the I underneath the square root, or is it outside of it? That's where it gets confusing. To avoid confusion, this is the way I recommend in my courses. But again, every instructor is different in that regard. It doesn't matter so much if you don't have a radical, or if you have fractions. Fractions makes it a lot easier to tell also. Let's take a look at this one. We got 6 minus square root of -9 over 3. Now this form we're going to see pops up in the quadratic formula. So they introduce it here to get you kind of used to how do you handle it when it's of this form and you have an imaginary part. Well, no matter what, whenever you run across a radical, you always simplify it. So let's start there. -9, that's -1 times 3 times 3. Remember, with square roots, we're looking for pairs of something. So here's a pair of 3s. Those going to come out in front as a single 3. And here's a -1. That'll come out as an I. So we're going to have 6 minus 3i over 3. Now there's nothing left inside the radical. We took the pair of 3s out, we took the -1 out, so the radical just disappears. Now notice in this one, we have an imaginary part, or a real part and an imaginary part. So we want to split it up. So put the 6 over the 3 minus 3 over 3 with an I to the side. So again, put the real part over the denominator, put the imaginary part over the denominator. And this simplifies further. 6 divided by 3 is 2 minus 3 divided by 3 is 1, so 1I just gives us I. And our answer is 2 minus I. Let's take a look at this problem. So we got 8 minus square root of negative 12 over 2. Again, before you go do anything in your problem, you should always simplify your radicals, especially when you're dealing with imaginary numbers. Sometimes if you don't simplify your radicals first, you'll get the wrong answer. So let's go ahead and simplify this. It's not the case in this problem, but it is the case in some problems. Now negative 12 is negative 1 times 2 times 2 times 3 all over 2. And we're looking for a pair of something. Here's a pair of 2, so the pair of 2 is going to come out in front as a single 2. And here's a negative 1. Negative 1 will come out as an I. So we're going to have 8 minus 2I, and we're left with a single 3 inside. Again, we can't bring 3 out because we have to have a pair of them. Now at this point, I notice I have an imaginary part, so I want to split it apart. I want the real part separate from the imaginary. So I'll put 8 over 2 minus 2 square root of 3 over 2I. So again, I split up the real part and the imaginary part. Now I just put the I to the side here because it's a fraction, so it's easy to tell where it's at. But let's see what happens once we simplify it. 8 divided by 2 is 4 minus, those 2's cancel, and we got square root of 3I. And you're welcome to leave your answer like that. If it bothers you, having it at the end because you're afraid you might get it, throw it under there by accident, put it out in front. It's not a real big deal. And we get that. I take either answer in my course. In reality, in the workforce, making a mathematical error, making any kind of error can be very costly to a company. They'd rather you write it the second way to avoid an error. Now these next ones revolve around a simple idea, and that is when working with complex numbers, we treat them just like they were variables. We're going to see there's some exceptions to that once we do these first ones. Okay, so we got negative 2 plus 5I minus 7 minus 2I. And let me go ahead and get my calculator up and running. We're going to find that you can also do these on your calculator, which is kind of nice. Now, you can't do 100% of this section on your calculator, otherwise I'd emphasize it more. But you can do some of the problems. Okay. Well, if these were variables here, if these were x's instead of i's, my first step would be to get rid of parentheses. Well, this first set of parentheses isn't doing anything, so I can drop them. So we got negative 2 plus 5i. And remember, if you have a negative out in front of your parentheses, it flips the sign of everything inside. So this is going to flip the sign of the 7 and of the negative 2i. Now 7 becomes a negative 7. The negative 2i becomes a positive 2i. It's like multiplying negative 1 through. Ignoring the fact that their I stands for imaginary, let's treat them like variables. If we are combining together like terms, we'd combine the numbers. Negative 2 and negative 7 gives us negative 9. And we'd combine together the i's. 5i plus 2i gives us 7i. And that's our answer. Now, if I was putting this into the calculator, I would just type in exactly as you see it. And if I can locate the calculator, there it is. Okay, so I do a beginning parentheses, negative 2 plus 5i. Now the I is down here. You see the decimal? If you do second decimal, it'll put the I on there. Closing parentheses minus beginning parentheses 7 minus 2, then second decimal, and then closing parentheses, and enter. And you see we got negative 9 plus 7i, which is what we came up with over here. Not hard by hand, even easier on the calculator. Okay, let's take a look at this one. We got negative 3 plus square root of negative 32 minus negative 4 plus square root of negative 18. And let me double check everything. Okay, looks good. Well, again, we want to simplify our radicals anywhere we can before we go on. So let's do that first. So I got negative 3 plus square root negative 32. That's negative 1 times 32 is 5 2's. 2, 4, 8, 16, 32. Minus negative 4 plus square root of negative 18. That's negative 1 times 2 times 3 times 3. Okay. Now we're looking for pairs of something. So, well, first off, this negative 1 is going to come out as an I. Here's a pair of 2's. They're going to come out as a single 2. Here's another pair of 2's. They'll also come out as a single 2. So we're going to have negative 3 plus 2 times I. And then we're left with a single 2 inside. Notice when they come out with multiplication between them. So this pair of 2's came out as this single 2. This pair of 2's came out as this single 2. And negative 1 came out as an I. Now over here, let's see what comes out. We got negative 1, of course. That's going to come out as an I. And we have a pair of 3's. That's going to come out as a single 3. So we're going to have 3i. And then we're left with 2 inside. Well, I'm going to get rid of these parentheses on this first one. So that gives me negative 3 plus 2 times 2 is 4. So we got 4i square root of 2. Now remember, if you have a negative in front of your parentheses, it flips the sign of everything inside. So this is going to flip the sign of the negative 4 and the 3i square root of 2. So negative 4 becomes a positive 4. The positive 3i square root of 2 becomes a negative 3i square root of 2. Okay. Now let's combine together numbers. Negative 3 plus 4 is 1. Now it should be called either combine together like terms, combine together like radicals, so forth. It should be an idea of combine together like items. If, excluding the number in front, if they're exactly the same, you can always add or subtract the numbers that are in front. When I say if they're exactly the same, see how this is I square root of 2 and this is I square root of 2? They're exactly the same, aren't they? So we'll add or subtract the numbers that are out in front. In this case, we got 4 minus 3, which gives us 1 I square root of 2, which simply gives us 1 plus I square root of 2. You could put the I after the square root of 2 if you wanted to, but that's fine for the answer. This is one of them. If you tried to put it into your calculator, it would not work, because calculator does not give you radical answers. Let's start a new page. Okay. Now I'm going to mention one fact here. This is there's two important facts to remember if you're going on to college algebra. One of them is that square root of negative 1 gives you I, and the second one is that I squared. And if you don't remember this, you kind of derive it if you remember the first one. We said square root of negative 1 is equal to I. Think what happens if we square both sides. So we square the square root of negative 1, and we'll square the I. Again, the square root and the second power cancel, and we get I squared is equal to negative 1. So that's a second important note to remember. We always want to write everything in standard form. The standard form says you cannot have an I squared. So anytime you run across an I squared, you have to rewrite it with a negative 1. And we'll see that in some problems. Now, it even goes further than that with when we got other powers of I, but we'll talk about those shortly. So let's take a look at this problem. We got 4i times negative 3 plus 2i and it says multiply. Okay, well, again, we treat it just like a variable, same as if you had x's there. This is a distributive property. We're going to take the 4i, multiply it times the negative 3, and we'll also multiply it times the 2i. So we got 4i times negative 3, and 4i times 2i. 4 times negative 3 is negative 12 with an I. Over here, 4 times 2 is 8. And we got I times I, which gives us I squared. Again, we always want to write it in standard form for our answer. And standard form says we can't have an I squared. But that's okay, because up here we said that in our note that I squared is equal to negative 1. So I'm going to have negative 12I plus 8 times negative 1. Which gives us negative 12i. 8 times negative 1 is negative 8. And not to be picky, but standard form does say the real part should go first. So it should be negative 8 minus 12i. And that's our answer. Okay, do this on the calculator. You just type in pretty much as you see it. So we got 4i. So do 4 and then second decimal. Beginning parentheses, negative 3 plus 2, then second decimal for the I, closing parentheses, enter. And that gives us our negative 8 minus 12i. Okay, let's look at the next problem. We've got 3 plus 4i times 7 minus I. Now, again, think of the i's instead of being imaginary. Think of them as a variable for now. We would FOIL this, multiply everything together. So we're going to take this 3 here. We'll multiply it times the 7 and times the negative I. And we'll take the 4i and multiply it times the 7 and times the negative I. So we take each term over here times every term in the second set of parentheses. So we got 3 times 7. We got 3 times negative I. We got 4i times 7. And we got 4i times negative I. I'm just following the lines to see what to multiply together. 3 times 7 is 21. 3 times negative I is negative 3i. 4i times 7 is 28i. And 4i times negative I gives us negative 4i squared. Again, I'm thinking just as variables at this point. Now, before, we'd always combine together like terms. Well, again, if they're alike, you combine them together. Here's a negative 3i plus 28i. I can combine those together. Negative 3 plus 28 gives us 25i. Now, this is not in standard form. We know we need to get rid of that I squared. So up here we said I squared is equal to negative 1, so we'll replace the I squared with negative 1. So we got 21 plus 25i. Negative 4 times negative 1 gives us a positive 4. And then 21 plus 4 is 25. So we get 25 plus 25i. Now you may be seeing a pattern at this point. When you got an I squared, basically what it does is flips the sign that's out in front. Notice how this negative 4 all of a sudden became a positive 4. So you don't have to actually write that out by putting negative 1 in there. It always works out that way. Okay, let's show this on the calculator just for fun. So we got beginning parentheses, 3 plus 4i. So 4 and then second decimal. Closing parentheses, beginning parentheses, 7 minus I. Minus. And second decimal for the I, closing parentheses, and then enter. And we get our 25 plus 25i. Okay, let's take a look at this one. We got 3 plus 2i squared. Again, we treat it just like a variable. And we're going to rewrite this. 3 plus 2i squared means 3 plus 2i times 3 plus 2i. Some people make the mistake of squaring a 3 and squaring a 2i, and you can't do that. The only time you can do that is when everything inside your parentheses is either multiplication or division. Here we have a plus. When you have a plus or minus in there, you have to just rewrite it this way and then multiply them together. Okay. So we'll take the 3 here, times the 3 over here, and times the 2i. And we'll take the 2i here, multiply times the 3, and times the 2i. So I got 3 times 3, 3 times 2i, and I got 2i times 3, and 2i times 2i. So I'm just following the lines to see what to multiply together. 3 times 3 is 9, 3 times 2i gives us 6i, 2i times 3 gives us 6i, 2 times 2 is 4, and I times I gives us I squared. Now I want to combine together these like i's. 6i plus 6i is 12i. And remember, we want standard form eventually, so we don't want that I squared there, so we'll replace it with a negative 1. Which then gives us 9 plus 12i. 4 times negative 1 is negative 4. And combine the 9 and negative 4. 9 minus 4 is 5, so we get 5 plus 12i. And that's our answer. Let's see this one on the calculator. Got beginning parentheses, 3 plus 2i. Remember, we do the I of the second decimal. Closing parentheses, push squared, and push enter, and that gives us our 5 plus 12i. Let's take a look at this one. We got square root of negative 18 times the square root of negative 12. This is one of them that if you dive right in with multiplying these two together, you get the wrong answer. Because a negative times a negative would give you a positive, and all of a sudden we'd lose something in our answer. But we remember, we should always simplify our radicals before we do anything else, so let's do that first. Negative 18, that's negative 1 times 2 times 3 times 3. Negative 12, that's negative 1 times 2 times 2 times 3. Now remember, the negative 1 will come out as an I, so that's going to come out. And we're looking for pairs of something. Here's a pair of 3, so a pair of 3 is going to come out in front as a single 3. So this first radical will be 3i square root of 2. Now our second one here. Again, negative 1 inside of a square root comes out as an I. And a pair of 2's. This pair of 2's comes out as a single 2. So that's going to give us 2i square root of 3. Okay, when we're multiplying two radicals together and they have numbers involved and possibly i's, what you do is you multiply each piece separately. So we'll multiply numbers together first. 3 times 2 is 6. Now we're going to multiply the i's. I times I is I squared. Now we'll multiply the radicals. And multiplying radicals, what you do is you multiply the numbers underneath and put them underneath a single square root. So we'll have 2 times 3 underneath a single square root. Well, again, we've seen this in a few other problems now. I squared, we know we're going to put a negative 1 in there. So we've got 6 times negative 1. 2 times 3 is 6. I can't bring anything out because remember, with the square root, we're looking for pairs of something. Which gives us negative 6 square root of 6. This is one that we can't do on the calculator because we end up with a radical answer, and the calculator does not work with radical answers, at least the TI3, TI4. Now these, let me start a new page. These next problems involve what looks like division. So we got 5 plus 2i over 3i. And I know it even says divide. Well, the main thing here is not necessarily the division. Our main goal is to put it in standard form. And some books will actually just say simplify, because it's then implied. And standard form means we don't want I down in the denominator. That's our main problem with this. Well, we've seen one way already to get the I to disappear. We said in the previous page that I squared is equal to negative 1. So if I had I squared, it would disappear. It would become negative 1. So you have to look at the problem and you have to think, okay, well, how can I get that to happen? If you get a single item down here with an I, then what you're going to do is you're going to multiply top and bottom by I. Then it'll become obvious in a second why we do that. Now up on top, we're going to take this I here, multiply it times the 5 and times the 2I. I times 5 is 5I. I times 2I gives us 2I squared. And then down below, 3I times I gives us 3I squared. Well, we've already said that we want to get rid of our I squared by replacing it with negative 1. So we're going to have 5I plus 2 times negative 1 over 3 times negative 1. And all of a sudden you notice something. The main problem I indicated was that we had an I down in the denominator, downstairs. Well, it's gone now, isn't it? Let's continue. We've got 5I, 2 times negative 1 is negative 2, and 3 times negative 1 is negative 3. Standard form says that you want the real part separate from the imaginary. So I'm going to put the real part over the denominator. So I got negative 2 over negative 3. And I'm going to put the imaginary part over the denominator. So we got 5 over negative 3 with an I to the side. Well, negative becomes positive, so that's 2/3. And I'll put this negative out in front. So 2/3 minus 5/3 I. Now these can be done on your calculator. The trick to it is, if you have more than a single number or single I in the numerator or denominator, top or bottom, then put parentheses around it. So when we plug this in, we want to put parentheses around the top and parentheses around the bottom. Other than that, we type it in as we see it, though we will have to do something after we plug that in. Okay. So I do a beginning parentheses, 5 plus 2I. Closing parentheses, divided by, beginning parentheses, 3I. Closing parentheses, enter. Get a decimal. If you remember from earlier in the course, whenever we get decimals, we can change decimals to fraction by doing math, enter. Yep. What did I do wrong? That's interesting. Let me try it again. Second enter. Push enter on that. And then do math, enter. Maybe my calculator's not set up. Okay. Let me go to mode. I thought I had that set up. Oh. Let me come down here. I went into mode, and I'm going down to A plus BI and pressing enter. Shouldn't have to do that, though. Might be a flaw with this this calculator. Okay. Now if I do second enter, bring up previous entry, second enter again. I get that. Now let me do math, enter. How bizarre. I assume it doesn't like the I in there. That should work on your calculator. I've done this on numerous times, so I'm not sure why that's not working on this. I think it's a flaw with this emulator. We'll pretend it is anyway. You don't have to do these by hand. I have students do these on the calculator all the time. Anyway, let's look at the next one. And then we'll actually try to change this one to fraction and see if it doesn't work. I wish I had another TA3, TA4 handy. I would just plug it in and see. Okay. Now this one we had a single item down here. Notice here we have two items. We have a real part and we have an imaginary part. Now, by the way, if you had a single item here being like a real number, like 5, then it's very simple. Just you go directly to split them into two separate fractions. So almost always you'll have an I down here. Now, if you have two parts like this, a real part and an imaginary part, what you're going to do is you're going to multiply the top and bottom by the conjugate of the bottom. Conjugate means the first is the same. So this is -3, this is -3. Last is the same. This is a 4i and this is a 4i. But the sign in the middle is different. Yeah, this is a positive, so this will be a negative. And again, you're going to multiply the top and bottom by the conjugate. Okay. Well, up on top, we're going to take this 2 and multiply it times the negative 3 and times the negative 4i. 2 times negative 3 is negative 6. 2 times negative 4i gives us, 2 times negative 4i gives us negative 8i. The nice part about conjugates is all you have to do is multiply your first parts together and your last parts. So negative 3 times negative 3 is 9. And 4i times negative 4i gives us negative 16i squared. So we got negative 6 minus 8i. And remember what I said earlier, our main problem is the I down in the denominator. But now we can replace the I squared with negative 1. Okay, so that's going to give us negative 6 minus 8i. 9, negative 16 times negative 1 gives us a positive 16. Which gives us negative 6 minus 8i over 9 plus 16 is 25. Now again, we always want to write it in standard form, so we'll split this up. We'll put the real part over the denominator, so negative 6 over 25 minus 8 over 25 with an I to the side. Now, actually I guess nothing simplifies, does it? So that's our answer. Okay, now let's plug this into our calculator, see how this works. My guideline is whenever I have more than a single number or single I, we have to put parentheses around it. We got a 2 here. I don't need parentheses around it. So when I plug it in, I want to put parentheses around the bottom part. I'm real curious now if this is going to work. So I got 2 divided by beginning parentheses, negative 3 plus 4i. So I do second decimal. Closing parentheses, inner. And we get decimals. So now we can change it. We do math, inner. And it does not work. That's bizarre. How about if I put in 0.24 and do math, inner. That works. 0.32, math, inner. And that works. Well, 6/25 and 8/25. You should not have to do that on your calculator. That's almost a guarantee. I won't put any money on it or anything, but I've had students plug these in for 15 years. So I'm guessing it's a problem with the emulator here. Some students hate doing these fraction ones, so they'll use their calculator on them. Okay, let's take a look at this one. I won't even try to plug it in the calculator since it's obvious from the last 2 problems they didn't work. This one probably won't. Now notice we have 2 items down here. We have a real part and our imaginary part. So again, this is one where we have to multiply top and bottom by the conjugate of the bottom. And then look at the bottom here. I got 1, so that's 1. I got 5i, so this is 5i. Conjugate again, the first part's the same, last part's the same. Sign in the middle is different. This is a positive, so this will be a negative. So we're going to multiply the bottom part by 1 minus 5i. And we also have to multiply the top part by it. Now I'm going to handle the top in a minute. But we got 2 minus 3i times 1 minus 5i. And on the bottom, again, the nice part about conjugates is all you have to do is multiply your first parts together and your last parts. First parts, 1 times 1 is 1. Last parts, 5i times negative 5i gives us negative 25i squared. Now up on top, I'm going to FOIL those, multiply them together. So 2 times 1 is 2. 2 times negative 5i is negative 10i. Negative 3i times 1 is negative 3i. And negative 3i times negative 5i gives us a positive 15i squared. Let me double check myself here. Usually I double check myself with the calculator, but obviously not here. And down below, we have an I squared, which we know becomes a negative 1. And again, that was our main problem. We had an I down in the denominator. You can't have that. So we see it's disappeared, so it's heading in the right direction. Back up on top, negative 10i minus 3i gives us negative 13i. Plus 15, and I squared becomes a negative 1. Down below here, negative 25 times negative 1 gives us a positive 25. So we got 2 minus 13i. 15 times negative 1 is negative 15. 1 plus 25 is 26. 2 minus 15 is negative 13. Minus 13i over 26. And again, whenever you have an imaginary part, you always want to write in standard form. So we want the real part separate from imaginary. So put negative 13 over 26 minus 13 over 26 with an I to the side. Now 13 and 26 are both divisible by 13. So this becomes negative 1/2 minus 1/2 I. Assuming I didn't make any basic math error. I'd like to be able to check my answers, but obviously it's not going to let us today or ever in that emulator. Let me start a new page so I can do the last problems. Okay, let's talk a little bit closer about what I to a power equals. Well, the first one's pretty obvious. I to the first. That's I. I squared, we said, was negative 1. That's one you have to remember, or you could derive from our the fact that square root of negative 1 is equal to I. Now, I to the third. Well, think of this as a variable. I to the first times I squared. I to a power times I to a power, you add the exponents. 1 plus 2 would give us 3. So if I multiply I times negative 1, that gives us a negative I. So you could derive that if you didn't remember it. I to the fourth. Well, I squared times I squared would give us I to the fourth, and negative 1 times negative 1 would give us a positive 1. Now we could continue with that, but what we're going to find is this repeats in groups of 4. And I'll talk more about what I mean here in a second. Notice I, negative 1, negative I, 1. I, negative 1, negative I, 1. And it'll continue. I to the 9th will be I. I to the 10th is negative 1. I to the 11th is negative I. I to the 12th is 1. And so on. So it just continues forever in groups of 4. Now let's take a look at our next problem. It says I to the 36. Now the instructions say simplify. It wouldn't even have to say anything. The fact that it's this way tells me that it's wrong. It has to be in standard form. So whatever way it's written, if it's not in standard form, you gotta put it in standard form. I could continue this table out to I to the 36, but that'd be quite a bit to do. So what we're going to do is we're going to take the power that's here and we're going to divide by 4. And this is old style division. Grade 6, grade 5, wherever it is. 4 goes in 36 9 times. 9 times 4 is 36. And then I get a 0 here. So this is 9 with a remainder of 0. Now we can rewrite I to the 36 power as I to the remainder when we're dividing by 4. Assuming I can spell remainder. Let's try it again. Maybe I'll just write it real bad and you don't know I don't know how to spell. We'll say that's correct. Sun was in my eyes. It's too early in the morning. Something like that. Okay, well we said the remainder is 0. So I can rewrite that as I to the 0. And anything in the 0 power is 1. Now that's kind of the oddball one, because that isn't in our table. I didn't write down I to the 0. Let's take a look at another example. Got I to the 82. Well, again, I don't want to continue this table out to 82, so let's divide by 4. 4 goes into 8 2 times. 2 times 4 is 8. Subtract that goes away. I bring the 2 down. 4 doesn't go into 2, so it's 0. 0 times 4 is 0. 2 minus 2 is 2, so this is 20 with a remainder of 2. So we can rewrite this as I to the second power, which I to the second power is in our table. It's equal to negative 1. So that's our answer. Now some of these you can do on your calculator. I got a couple here I've shown by hand, so let's go back and do them on the calculator just to see what happens. Kind of leery of the calculator since that one didn't work when it should have. But I to the 36. Sometimes you get bizarre results when you do these I to a powers on a calculator though, so we'll see. second decimal, and then I'll do caret for the power, and then 36. It does these numerically, and rounding error pops up on some of them. Like on this one, it's telling us the answer is 1 minus 4e negative 13i. What that means is we got 1 minus, and this is scientific notation. 4e to the negative 13 means 4 times 10 to the negative 13 power to the I, or I. Now, 10 to the negative 13 means you move your decimal place 13 places to the left. So let's see, 1 minus point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, I. Assuming I counted enough zeros there, that's what it equal to. Well, if I told you guys I'm going to give you a $0.00004, what am I giving you? I'm giving you nothing, right? So that if I did any kind of rounding, that would go to 0. So our answer is just 1. The basic guideline on this is if you end up with an E part, that part you just ignore. That part just would drop away. And then your answer would be this right here. Let's see if it gives us an I to the 82. You'll see that pop up a lot when your numbers become large. If you did like I to the third, you wouldn't see it. Like if, for example, if I did second decimal, caret 3. See how we don't see it? But I to the 82. Second decimal, caret 82. You see, we see it again. Now again, the answer to this, we ignore that part of the E in there, so our answer would just be this negative 1. So you can do them on the calculator, but they don't work quite as nice as we'd like. Now this one, we got I to the negative 14. Remember, we don't want negative exponents, so let's handle that first. And I can always create a fraction by putting it over 1. Remember how we get rid of negative exponents. You take the part with the negative exponent opposite of where it's at in a fraction. So this I to the negative 14 I'll take down to the denominator. And it becomes I to the positive 14. When you take anything opposite of where it's at in a fraction, the sign of the exponent changes. Well, 14. Let's go ahead and divide that by 4. 4 goes into 14 3 times. 3 times 4 is 12. Subtracting those, 14 minus is 2, so we got 3 with remainder of 2. So we're going to have 1 over I to the second power. Again, we put the remainder right here. But I squared, we know what that is. That's negative 1. So I have 1 over negative 1, or that's going to give us negative 1. This might be small enough to where I wouldn't get a numerical error on the calculator. Let's see. Do second decimal, caret, negative 14. And again, I'm wrong. So you may find those easier to do by hand. And that was our last problem, and that's complex numbers.